Hello, sixth graders. We are in our rational numbers unit. This is lesson 3A, lesson prime factorization. We have 3 learning targets that you need to write down. I can identify numbers as prime or composite. I can use prime factorization to determine the factors of whole numbers. And I can express a whole number as a product of prime factors with exponents. A little review for you here. We learned about this in Unit 0, prime and composite numbers. Prime number is a whole number greater than 1 that it has exactly 2 factors, 1 and itself. So a couple of vocab to write down. Composite number is a whole number greater than 1 that has more than 2 factors. And the factors are the numbers that multiply to give us a number. Okay, so for example, 2, the factors, the numbers that multiply to make 2 are 1 and 2. And since that's the only numbers that multiply to make 2, then that's a prime number. Okay, numbers 0 and 1 are neither prime nor composite. This is all review from Unit 0. Okay, so we're looking at a few numbers here to determine if they are prime or composite. So we would look at the factors, the numbers that multiply. Well, I know 1 and 17 are factors, and there's no other ones, so that's a prime number. Where 12, you've got 1 and 12, 2 and 6, 3 and 4, that's more than just 1 in itself, so that would be composite. Again, I'll review here. Try these ones on your own and then come back and check when you are ready. 11, the only factors are 1 and 11, so it is prime. 15, you've got 1 and 15, of course, and then 3 and 5 as well, so therefore that is composite. 24, 1 and 24, 2 and 12, 3 and 8, 6 and 4, lots of factors on that one, composite. Okay, some more vocab here, prime factorization. So every composite number can be written as a product of prime numbers. The product is the prime factorization of the number. So prime factorization, breaking numbers down into all of their prime numbers. You can use a factor tree, okay, these down here are factor trees, to find the prime factorization. They are both examples here of 60. So if you look, they split it up differently. First, they split it up 6 and 10. The other side here is 12 and 5. And then you keep going, and either way, you're going to end up with the same numbers at the bottom. So we'll get more into this as we go here. But prime factorization, breaking a number up into all of the prime numbers multiplied together. So there's 2 methods that we use. Factor tree is what you'll see me use most often, but if you are more comfortable with the other method, then do that one. So we start with our number here, 24. And we are looking to split this into 2 numbers that multiply to give us 24. Well, there's lots of different ones you could do. 2 and 12, 3 and 8, 6 and 4. I'm going to do 2 and 12. Now I look at either of those and ask myself if they are prime. 2 is prime, so I'm going to circle it. 12 is composite, so we can split that up again. And I know I can split that between 2 and 6. You also could have done 3 and 4. 2 is a prime number, so I circle it. I just circle all the prime numbers. It tells me that they're done. 6 is composite, so that could be split between 2 and 3. Both of those are now prime, so I'm done. There's nothing else to split apart. So then I write this out as the numbers that are being multiplied together. So 2 times 2 times 2 times 3. So you could write it that way, or you could write it with exponents. Since 2 is being multiplied 3 times over, you could write 2 to the third times 3. Both of these are the same. So that's the first method, the factor tree. The other one is dividing by prime numbers. So we take 24, okay, and I'm going to write it a little differently here. I can divide this by a prime number of 2, so I'm going to write that on the outside. And I know 24 divided by 2 is 12. And then I can divide again. 12 can be divided by 2, which 12 divided by 2 is 6. 6 I can divide by 2, and then 6 divided by 2 is 3. So now, these numbers that I have here on the outside, those are my prime factorized numbers. So 2 times 2 times 2 times 3. Or again, with the exponents 2 to the third, because there's 3 of them, times 3. Either way, you end up with the same. So whichever method makes more sense to you. Like I said, you're going to see me using the factor tree. You have to decide what is better for you. All right, we've got 3 examples here for you to try. Come back and check or watch along if you don't feel comfortable yet. So starting with 18, we're going to split this into 2 numbers. I'm going to do 2 and 9. Okay, 2 times 9 is 18. 2 is prime, so I circle it. Now on to the 9. That can be split between 3 and 3. Both of those are prime. So we have 2 times 3 times 3. Or in exponential form, 2 times 3 squared, because there's 2 3's on there. Just splitting it into prime numbers. 28. Well, I know that it's even, so I can divide it by 2, which is 14. You could have also done 4 and 7. 2 is prime. 14 can be split between 2 and 7. Both of those are prime. They cannot be split anymore. So we would have 2 times 7, or 2 squared times 7. Either answer is fine. You just have to pay attention if the question is asking you for expanded form, like this, where it's all written out, or exponential form, where it's written with exponents. Last one, 16, 2 and 8. You also could have done 4 and 4. 2 is prime. This can be split between 2 and 4. 2 is prime. 4 can be split 2 and 2. So you could have 2 times 2 times 2 times 2, or 2 to the 4th, because there's 4 of them. All right, factoring an algebraic expression. So now we've got some letters in there. So I'm going to pretend that the letters aren't there for right now, and I'm just going to look at this 6. So I know that 6 can be split by 2 and 3. Both of those are prime. Now, the a and the b are variables. We don't know what they are, so we don't know the numbers. So now at the bottom, I'm just going to have 2 times 3, and then all I do is I include the a and the b. That's all it is, because those could be any number that we plugged into it. So anytime that there's letters on there, or variables, just ignore them until the end. Okay, there's one here for you to try on your own. 18xy. So again, I'm going to ignore the xy, and then 19 I'm going to split. This time I'm going to do 3 and 6. Change it up a little. 3 is prime. 6 can be split into 2 and 3. So I would have 2 times 3 times 3, and then I have to include times x times y. So on here, my x is bigger than the other one. Otherwise, you could have used the dots. You could also write it with exponential form, 2 times 3 squared, because there's 2 of them, times x times y. Anytime there's letters on there, ignore them until the end. That is all for prime factorization. If you are confused or need some more help still, go back, rewatch the video. Otherwise, come with questions tomorrow.